Can't believe it. Somebody left their glasses and their notebook over here.
Yeah, I know.
Sunglasses, they have a way of going on vacation. But where are all the water bottles we had earlier this semester?
No.
Okay.
Did the SI prepare ever say what they do on the study session or no?
Same schedule that's in discussions.
Okay.
And let's get going with lecture. And I'll make a comment about that. Yeah, go to. Okay. All right. All right. This is not working.
Try that one.
Give me $20. Okay, this is working. Ooh, I recorded that into the lecture. That's going to be on YouTube. Okay, my wonderful students, welcome. I was hoping to cover impulse and momentum and uniform circular motion, which is in Chapter 3. We're going to save uniform circular motion in Chapter 3 till after Exam 1, but we're going to tackle Section 4-1 today. So we're kind of hopscotching a little bit. Before we do that, I want to make a couple announcements. And Carolina, I know you were asking me about what is this business? Lecture 7 noon, and here's lecture 7 a.m. in the grade book. And what are these numbers out here, 5.05 and stuff like that? Well, what that is me messing around with the iClicker software, and I don't have a Windows computer, and we're running it off the Windows computer here in the lectern. And so when I am near a Windows computer, I'll try stuff out. And what I tried yesterday was uploading the data, your data, from Lecture 7, Tuesday, just to see what it looked like. And this is what it looked like. Now, I'm normally going to post every 2-3 weeks a summary of your clicking data. I won't be going lecture by lecture this way. But I want to see what the data looked like and stuff. And the way that this works is I have iClicker set to give you 0.01 points for every question that you ask. And then 1 full point, Carolina, for every question that you answer correctly. Now, your 25 out of 25 points in your semester grade for participation come out of the little .01s and 04s and stuff. Okay, Nicole? So, but I also keep track of how many you answer correctly. And the reason for that is, at the end of the semester, and I'm not sure I mentioned this already in lecture, but I'll mention it now. At the end of semester, I traditionally give students a 4-point bonus, 4 bonus points, if they have answered 75% of the clicker questions correctly. So I do care about participation, and I do care about correct answers. All right, so when you're in class, don't just click A for or Christmas treat or anything like that. Try to answer as well as you can with the correct answer. And then at the end of the semester, if you get 75% of all the questions correct, that'd be like a B, 75% B. You'll get 4 bonus points. Okay, so try to shoot high. We have an exam coming up. I'll talk to you about the structure of it in just a minute. But before we do, I want to point out to you the usefulness of the discussion area in web courses. And there was a bunch of people asking questions about Homework 5, the question about vertical F1 and F2, horizontal F2 and stuff. And in discussions, I want you to try to do the following. I want you to use it as like a study tool. All right. Now, a bunch of students were peppering up discussions with a bunch of questions yesterday, and that is good. We want you to do that. And Darianne periodically strolls through there and tries to coach people, and I do the same. I did some this morning or last night, and then Caroline the same. And I also noticed some of the classmates contributed some good advice. All right. So you can use it, Danielle, in a way that is helpful to, I'm just practicing names. It's helpful to study. It's like a virtual. So if you can't make it to office hours with Caroline, you can't make it to office hours with me, or you don't make it to office hours with me, you could go to discussions and get some coaching and tips and stuff like that there. Now, when you're in there, if you have a question and you send it to me on messages in the inbox and everything, I'll tell you, post this question in discussions, and I'll answer you there. And that's so that everybody else in class can benefit from your question. Everybody's going to be reading the questions and stuff, and when you're there, make the title as clear as possible. Don't just say, "Help me." Type in homework 4, how do you get the brain burner equation? Or something like that, so you know what homework assignment it is, or like what lecture notes it is, and what the specific item is about. Then that'll help people go in there and help you, or go in there and get help from your post. Secondly, this is what the creation panel, this is how you set it up. All right, so you're in there and you're typing, and this is a student typed in a question here, and it looks pretty good. And they used a bunch of the features, like over here, F1 and F2, those are subscripts. They use the subscript and superscript. Well, they use a subscript button right here. They also have a numbered list. That's this one right here, the number list button. So this thing is a nice little editor. I also want you to click where it says allowed threaded replies, if you will. And that makes the thread more efficient for studying, because if you don't do that, people will reply to something you say, but it'll be at the end of the list. And so you might not even realize that they replied to you. So if your name is Josephine, somebody could reply to your thread, but if they don't say, "Hey, Josephine, here's my answer," if they don't say that and it's not threaded, you don't know that they've replied to you. You won't know that they've replied to you. But if you check threaded replies here, that'll be good. It will work. It's much more efficient. Okay, also click the thing that says allow liking. All right, and because that'll help me. And it's not like Facebook liking exactly, because it doesn't, it doesn't light up without. Well, I guess it does say how many likes you get, but anyways, it helps. These two things. All right. Now, another thing that I want you to do is, if down here at the bottom, if you notice, it says 10 and then the little upside down V to represent superscript or exponent, and then a 2 for 10 squared in parentheses, 10 in parentheses, quantity squared. You can use this little button up here The Pilcrow button, that's a formula maker. It's WYSIWYG. What you see is what you get. And it works pretty nice. And it's based on the LaTeX typesetting program. It works really nicely. And I invite you to use it. And I've seen some of you use it. So you can fool around with that. It's not too hard to use, and hopefully you'll get the hang of it. All right? Now, if you don't know what this symbol is called as a public service, I did look it up this morning. It is called a Pilcrow. I have no idea where that comes from, but apparently it's from dictionary.com. It says late Middle English and Old French, the Pilcrow symbol. Anyways, that's the one that lights up the equation editor. Okay, so use discussions carefully, and it's a very useful study tool if you if you care to make it work for you. All right, and you want to make it work for you, especially to prepare for exams. Now, I'm just going to go through a short spec sheet of concepts. No, a short spec sheet of information about the exam, 50 points. We're going to tackle everything since January 10th, so that means lecture 1 through lecture 8. That's today's lecture. It also means everything through from the introduction in the textbook up to section 4.1, which we're going to tackle today. And now here, make a side note to yourself. Uniform circular motion, we're going to postpone that till after the test. I was hoping to cover it today, but we don't have quite enough time for it. So we're going to do a little bit of hopscotching, but other than that, it's up to 4-1. All of our homework problems, except for homework 0, the attendance homework. All right? So as I've said, we've got a lot of stuff to think about. Now, does anybody have a question here? I invited somebody to ask a question in lecture concerning this type of stuff. The student's probably not here. Kane. No, but I'll get to that in a minute. Yes.
I had something about the participation points again. So, like, if you get 0.05 out of 0.05, you answered all the questions, and then if you get, let's say, like 3 out of 5, that means you got 3 out of the 5 questions.
3.05, yeah.
Okay, but it's really for the
Yeah, but you're never going to see that. I'm always going to put up whole numbers for both categories.
Okay.
Yeah, so I was just fooling around with that. Question in the back.
Last semester, when it was time for an exam, one of the professors was reopening the homework or the quizzes for us to study over again. And I don't exactly know if you can do that.
Okay.
I know that you're going to open the homework.
Yeah. So the question is, can you reopen the homework? And no, I traditionally do not do that. However, if you've done some of the homework, at least one attempt, you can go back and look at it and use it as a study tool with a friend, a study partner, and we're going to have a ginormous homework assignment this weekend. It's going to cover stuff from today's lecture. There's going to be a few review questions, okay? Maybe a few from homework 1 through 5. And I'm also going to reopen homework 4, so you can try one more time with those 2 brain burners. Now, normally I don't do that right before the exam, but I think it's appropriate. So we're going to have a lot of homework to tackle this weekend, but no, I'm not going to go back and reopen all the homeworks 1 through 5. But I am going to reopen 4, and homework 6 is going to be a good big homework study assignment, okay? And I understand why you're saying that, but I don't normally do that. But if you have a friend, you can always look at if you didn't take any attempts on like homework 3, but your friend did, then they can just print it out or open it up on their computer and you can study from it. What's that? You'll know if your answers are right if it says 1 out of 1 or 2 out of 2 or something. If you get it wrong, it just tells you what the. So then you got to, if you get it wrong and you still don't know why, then you have to post a question in discussions. All right? And look, I'm not, you just gave me this look that was exasperated. I wasn't making fun. That's how I want you to handle it. And it'll be useful for you and for bunches of other people. Because if you have a question, there's a good chance that somebody else will. So if you post it in discussions, then everybody will be able to benefit from it. And we'll be in there, coaching and stuff. So definitely do that. So if you still need help with a specific problem, you can post in discussions, and that'll be your follow-up. Okay? All right. Now, I don't see anybody asking any other questions, so I'm going to ask a question. Dr. Brickner, are you going to give us a study guide for exam 1? The answer to that question is no. The full answer to that question is the following. No, I never make study guides. Your lecture notes are your study guides. This is university now. You're in a serious situation. Take your lecture notes as if your exam depends on it. And re-listen to YouTube as if your lecture notes, as if your exam depends on it, because that's your study guide. All right? All right. Now, for exam 1, I want you to bring the following items. UCF Scantron. It looks like my animation is blooped up here. I know what it is. Hold on. I've got 2 slides here. It's the second slide that we want. Okay. This one's got the... All right. This one's animated properly. Yeah, the UCF Scantron, they have them in these vending machines. Go up to SGA office, 2nd floor of Student Union, and they give you one for free. 1 per day or something like that. I guess. I've never done it, but... and it's the one that has the UCF logo on it, the Pegasus logo. It looks like that. And it's raspberry colored. Also bring your iClicker 2 and make sure it's registered. All right? And it's got to be iClicker 2, and the reason for that is with your iClicker 2, we're going to click in some calculations. You'll have, 1 or 2 brain burners, as always, on the exam, and if those involve calculations, you'll be typing in the numbers, like negative 4.7 or something like that. You'll be typing that in with your iClicker. And the benefit to you is that you can type in a number that you figure out, and then also when iClicker is done, it generates a spreadsheet of everybody's answers, and I can load that spreadsheet into my Apple Numbers program, and I can sort all the answers, 400 students, and look through for everybody that's got negative 4.7, and what I'll find is somebody that typed in positive 4.7, and if I decide, I'll give them partial credit. So like maybe 1 out of 2 points instead of a full 2 points. All right? Or if I see somebody that's got negative 4.69, I might say, all right, I'll give it to them. They didn't round off right, but, or I might give them 2 out of 3 points or something like that. And you can't do that with Scantrons. You will have a few simple Scantron calculations, or you will have a few simple calculations. Like we had a homework problem. What's the weight force on a 4 kilogram suitcase? Okay, the weight force is mg, 4 kilograms times 9.8, answer 39.2. That was multiple choice on the homework, and you might find a cinchy calculation like that in the Scantron. All right. Now, some of you are asking me, how many Scantron questions will there be? How many clicker questions will there be? All right, now I don't know yet. I haven't written the exam. But probably about 2 or 3, maybe 3 or 4 clicker questions, and there'll probably be calculations of 2 or even 3 points. So let's say that you have 2 2-point calculations and 1 brain burner 3-point calculation. So that's a total of 7 clickers, 7 points, 3 questions. Okay, so that means that for the 53-point test, I have to have 43 dots on the Scantron form. So you'll be filling out 40-something Scantron dots, and then 2 or 3, 3 or 4 clicker items that you'll type in an answer. Right? So it works good. Also, I don't know if I mentioned this, but the first few items on the exam, on the Scantron part, are formula questions. Did I go over the formula matching last time? Okay, what I normally do, the first 4 or 5 questions, maybe 5 or 6 questions, I'll have a list of formulas or equations or something, and then over on the other side of the page or above it, I'll have A, B, C, D, and E, and I'll have like the concept or the name of the equation or how you use it or something like that, and you'll match up one of those concepts to the equation itself. So it'll be equivalent to having a standard formula sheet, but you'll get some points by recognizing each of the formulas. So you don't have to memorize formulas for the exam. You have to recognize. I'll put the formulas on there, and if you can recognize them, what the name is, what they're used for, stuff, what the concept is behind the equation, then you'll get a point. And that's usually 3 or 4, 4 or 5 questions, 5 or 6 beginning. Then maybe some true false, and then a bunch of multiple choice for the rest, and then the clicker questions. So, in addition to the iClicker in class, it has to be registered. Now, if you haven't registered, although most of you have done that, it's this little iClicker tab over here on the left side of our web courses pages. This is a close-up of it here. And just click on that, and you type in the serial number. And if you're in Safari, you have to turn off cookies or turn on cookies or something, and then it'll register. Okay, you've got to do that. Otherwise, I won't know whose clicker it is, and I'm not going to go and look. All right, so you've got to have that done by Tuesday. Okay, number 2 pencil for the actual dots. Bring a good eraser like one of these pink rectangle jobs from 2nd grade. And the reason I say that is because a lot of times students will come in with no eraser, or the eraser on their pencil is so old that it doesn't erase, it merely smudges, or it's so rough that it wears a hole in the Scantron. You can't grade a Scantron with a hole in it, right? But if you bring one of these little rectangular jobs, you should be good. Calculator, all right? So if you have a tiny, nice one that's solar, it has a square root key like this one on the right, or excuse me, this one on the left, that's good. If you have a square root key, ding, you should be able to handle everything. We're going to do some square rooting in a minute. All right. If you don't have a square root, if you don't have a calculator, you may not use your cell phone. Okay. So scientific calculator like this one over here is fine, but you got to know how to use it. I probably won't have time to tell you how to use it. So if you don't, so practice your squares and your square root keys and stuff like that, and you should be good. If you have a graphing calculator, you can use it. Okay. But you got to know how to use it, because I won't be instructing you on how to use it. Question over here. Elizabeth, you may write on the test. There'll be scratch work areas, especially where the clicker questions are. It's because you got to write stuff down before you actually, click in the answers. Okay, so you'll be turning in the test, And you can write on it. You'll put your name on it, your PID, and then you can write on it, sketches, little diagrams in the margin and stuff like that. And then you'll do your Scantron name, and then you bubble in your PID, and you'll turn that in as well. Okay, so question over here. Different forms? You mean like not everybody's taking the same test? You mean like I normally do things? Yeah, that's normally what I do. Yeah, so you'll see it. It'll work. It works good. Okay.
So how are you working the iClicker questions?
The iClicker questions you'll do on your own at your own pace, and I'll have instructions on how to do that. And the iClicker questions will be the last page. They'll be printed for you, so you don't have to use them. I won't be running the screen. It'll be on a page, and there'll be instructions right above that on how to actually do it. Because you got to click things in and then select the next one and all that stuff. All right, now, okay, so you can't, even though cell phone calculators are pretty nice, I've got one, I use it and stuff. You may not use it on the exam. You may not use your cell phone on the exam at all. Just put it in your pocket or your knapsack or something. If we see it out, I'm going to take your exam and give you an F and then report you through the discipline procedure. So don't do it, all right? We caught a guy doing it last semester, okay? And his grade was in the toilet because of that, all right? So just be ready, just study, and no cell phones. All right, now I want to double check the logic in homework 5. Get your clicker ready. We're going to do some clicker questions here. This is an instance here of the net force question. How big, this? I think this is the very last question, item 19. What's the size of the net force? Now, question 18 was, what's the direction? And I gave you, you had 2 different decisions to make. This one, we're trying to figure out the size of it. Now, the thing about this is, a lot of people were in discussions asking me, well, Dr. B, what about this minus sign? What do you? And so I'm going to ask you some questions about the minus signs and how to handle it. And we're going to figure out the size of the net force for this baby. All right, and we're going to let the numbers do the talking. So get your clicker ready. And I'm going to ask you a question that you're going to think, Dr. B, what on earth does this have to do with net force? All right, it's multiple choice. And here it is. Go ahead. You're 200 meters from the Pegasus Circle in the Student Union, which you're not supposed to walk on. Where are you? Boy, do you hear how quiet it got in here?
That's so aggressive. I'm supposed to walk.
You're not supposed to walk on. Did you ever hear that? Yeah. No, in the Pegasus Circle in the Student Union. Now you got to make a judgment call here. This one, I'm going to give you the benefit of the doubt on this, but you have to give me your best judgment call. You're okay, no problem. Good. Clicker.
Is this supposed to be multiple choice or typing this?
It's supposed to be multiple choice. Just type in a letter A, B, C, D, or E, and then hit the send key. That's right. I've set it up for typing in a long answer, but all you have to do is type in one. Type in A, B, C, D, or E, and then then hit the send key. Okay, 30 seconds. Where's Waldo? $20 seconds. You're so organized.
I know. I have to be.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. 125 students go to the display. And you can see, whoa. Look at, this is interesting. Very few people chose B. And go back to laptop now. B was the library. So I guess that means hardly anybody ever spends any time at the library studying. Anyways, the answer to this is all of them are correct. All these locations are actually 200 meters. And I'll show you. But the thing is, if you just know the distance, you can't really say definitively where you are. And the same thing, if you know the magnitude of the net force, you can't tell from that the direction of the net force. So the direction and the size of a vector, whether it's a net force or a position vector or velocity vector, the size of a velocity vector is the speed. If all you know is the speed but not the direction, you know how fast you're going, but you don't know where you're going. It's like driving a car with the windshield painted over with paint. All right, you might be going 25 miles an hour, but you have no idea where you're going. All right, so just knowing the distance or the net force, size, or the speed doesn't tell you exactly where you are, where the force is pointing, or where you're going. So and I just took a minute here this morning, a few minutes. This is one of my favorite websites, gpsvisualizer.com. It's really cool. It allows you to write in the coordinates or the name of 2 airports or 2 towns and get the distance as a crow flies in miles or kilometers. So you could type in MCO for Orlando and then EWR for Newark Airport up in New Jersey, or has anybody ever flown to Heathrow in London? What's the code for Heathrow? What's that? HR? LHR? Okay, so MCO and then LHR, and you can see the direct flight route, if it's a direct flight, to London Heathrow, etc., or Paris Orly, or any other airport in the world. Anyway, so one of the things it lets you do is specify a location and then draw distance rings. And that's what I did here. I specified the location. Here's a close-up. Right here in the middle, that's the center of the circle at the Student Union. And this red circle around it, that's 200 meters away. All right, and so you can see, and then I looked at this, okay, Chick-fil-A is a little too close, but UCF, the library, yeah. Engineering, too, yeah. Starbucks in HPA, yeah, et cetera, et cetera. So all those places are right. So you could be anywhere on this red circle. The distance does not encode the direction and vice versa. All right? They're independent concepts. All right, let's do another clicker question. For this instance, vertically upward, i.e. 10 newtons, and horizontally leftward, i.e. negative 6.9 newtons, which of these is the correct version of the Pythagorean theorem? Now, I probably won't ask you a question like this on the exam, but you may have to make a decision like this for an iClicker question on the exam. So this is kind of a mental preparation for you. And hey, you guys, when you have a decision, write down what your decision is. Which one do you think is the correct one? And I'll give you 20 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ching. 130 students answered. Very nice. And most of you got it right. Okay, C is correct. Now, to help you and to emphasize a general exam taking strategy on a multiple choice exam, let's go over and look at this list of options A, B, C, D, and E, and let's look at some of the reasons that A, B, and D are incorrect. All right? Now, option A, first of all, it's got a minus sign here. That's not the Pythagorean theorem for distance. Spatial distance, that's got to be a plus sign. Now, in the theory of relativity, when you bring in time as the fourth dimension, then you bring in a minus sign. But for regular spatial distances, a plus sign. Also, what else is wrong with A? 6.9 and what's wrong with it? Yeah, no, there's no negative there. Okay? Now, this one's got a negative, and this one's got a negative. Uh-oh, this one down here has a minus sign. So option D, minus sign, cancel that one out. And remember, when you're doing these problems, if you get stumped and you can eliminate one or two of the alternates and then make an educated guess on the others, then that'll be really helpful. Okay. Option B. Another one, this has got a plus sign here, but this is a 6.9, not a negative 6.9. Right? And the directionality information is in the Pythagorean theorem if you do it correctly, but it vanishes when you calculate because negative times negative right here is positive. All right? So let's get this thing figured out. Graphically, if you have the two constituent force vectors and their tails are both traced in on this yellow dot, in other words, the dot that symbolizes the center of mass of the object that you're studying, then the left side and the top are copies of the right side and the bottom. Right? It forms a rectangle. Because the two constituent forces are at right angles like this. Right angles like this. Okay? You have a rectangle. But if the two constituent forces were slanted, you'd have a parallelogram. Okay? But you'd still go with the diagonal from the center of mass out to the opposite corner, and that is then the arrow for the net force. Now I'm going to park my arrow down here below the diagram. Okay? You can do the same thing if you like. All right? Now that arrow, based on an accurate sketch, tells me the approximate direction. All right? And remember, in this class, the directions that you want to use to describe a vector: north, east, south, and west, and then northeast, southeast, southwest, and northwest. Just 8 different ones. This one's northwest. All right? And then, of course, you want to calculate the actual size of the net force. So 6.9 negative quantity squared is positive 47.61. And if you haven't figured that out, go ahead and check it on your calculator. Make sure you have your calculator out. We're going to be using it for the rest of today. And then, of course, 10 squared is 100. So 100 plus 47.61. And then square root that. And that tells you the number of newtons that you've got. So approximately 12.1. All right. Question? Yeah, if F1 was pointing down, if you had a southward force, then you'd have a negative, like negative 10. But then he squared anyways, you still end up with a positive 100 there. So, okay. All right, let's keep going. We've got a lot to talk about. Next topic, and this is 4-1. This graphic, it says force view in the green bar at the top of it. That's actually from page 46, I believe, in the textbook, section 4-1. It's discussion of two skateboarders, Bob and Carl. And what if you've read that, which you were supposed to do for the homework, you know that knowing the masses and the initial conditions, and then the size of the interaction force, and then the duration of the interaction, delta t, you can figure out, using Newton's second and third law, the forces and the accelerations in the force view, and figure out the final velocities of Bob and Carl. So in this example from page 45 and page 46, I said that the interaction force, as a matter of fact, is right up here, right at the upper part of this graphic. Interaction force is 500 newtons. Positive for the force of Bob on Carl, and negative 500 newtons for the force of Carl on Bob. All right? And that minus sign encodes the direction, left and right. Left for the minus 500, rightward for the positive 500. Now, if you work out F equals ma and the interaction time and a delta t, you can figure out v final velocity for both of these guys. For Bob, negative 3.00 meters per second. He's the small guy, right? He's 40 kilograms. And Bob's a little bit bigger. Excuse me. Carl's the small guy, and Bob's the bigger guy. Carl, final velocity, is positive 6.00 meters per second. All right? Now, in the force view, you can use F equals ma and the third law and figure out, get a lock on all these numbers. All right? And we're in that example, we were shooting for final velocities for both guys. And we saw that up here in the front. The two guys, let's see, Jake and Javier, they pushed off from each other. Is that, Jake, are you here? Yeah, okay. All right. And Javier, where are you at? Okay, good. All right. Those two guys pushed off, and they both had a change in the velocity. You know, one to the left and one to the right. All right. Now, there's another way of looking at it. This is using F equals ma. Everything's good. We've done it. Vix times t plus 1/2 at squared if you want. But there's another way to look at it, the skateboard interaction. And that is using the concept of momentum. Now, here's the spec sheet from page 46. I typed it all out. All right, and we got a lot of stuff. You can work through those calculations, re-verify them. All right, that's from the force view. Accelerations, forces, stuff like that. Now, in this, I want to draw your attention, your googly eyes, to a pair of quantities that are equal size for both. All right? One of them is the interaction time, the contact time, okay? Because as soon as they break contact, they're no longer interacting, right? So if one guy's in contact for 0.48, so is the other guy. Right? The other quantity that's the same is, whoa, I just bustled mine. There we go. Okay, I got to be careful there. The other guy that is important is the interaction force. Okay, now I put a red box around F equals 500, but really there's 500 Newton to the right, and a negative 500 newtons, that signifies leftward. All right? And so Bob pushes on Carl to the right, Carl pushes on Bob to the left, but the size of the forces are the same. All right? Now, because these are the two quantities that are equal, I want you to think about combining them into one quantity by multiplication. So here's your next iClicker question. What's the product of interaction force, 500 Newton, and elapsed time, delta T equals 0.48 seconds? Product means multiplication. And yeah, I see a bunch of you with your calculators out. You can do it in your head if you think about it, but if you don't have if you have a calculator, may as well use it. Okay, it's interesting. 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Nice. 131 students answered. Good. Go to the computer display for a second. All right, we got a little bit of conflict between option C and option A. All right. Correct answer is just option C, a force times a time. A Newton times, so it's a Newton second. And I want to draw your attention up here to these equations now. Let's look at how those numbers combine. And this is not the same calculation, but 1.0 Newton seconds, if you look up here on the top, that's the same, this second part of the equation, the top equation, says 1.00 kilogram meter per second squared. That's a Newton. All right? And then the other part is 1.00 seconds. All right? That's the multiplication. That's the two numbers that are being multiplied by. But now look at this. A second up here cancels with one of the seconds down here in the denominator. All right? So really, your denominator is just seconds. So your numerator is kilogram meters, as it was, and the denominator is seconds. And that's important for us because it shows you that F times delta T is the same units as a mass times a velocity or speed. All right? So make a note of that. F delta T has the same units as mass times velocity. All right? Kilogram meter per second. Now, there's no fancy name for kilogram meter per second. That's just what it is. All right? What's that? Yep, F delta T is equal to kilogram meter per seconds. Because F is a Newton and delta T is a second. So now, second question. I want you to apply your brains. All right, Newton's second law, F equals ma. Another way to write it, F equals m delta V over delta T. So how would that change? What would F delta T be equal to? "30 seconds. "20 seconds. Make your decision. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, 130 of you answered. And most of you got it correct, m delta v. And so that brings us to another version of Newton's second law called the impulse equation. Right? The impulse equation is this: F delta t is equal to m times delta v. That's Newton's second law, but kind of rearranged. The furniture is kind of rearranged, but basically it's Newton's second law. And it's known as the impulse equation. Now the impulse is the left side, F delta t, that's the impulse. You know, a force times a time. Okay? And m delta v is going to get us to the concept of momentum. All right, so F delta t equals m delta v, the impulse equation. Let's keep going. According to Newton and Galileo, the skateboarders are in contact for a certain amount of time. Their interaction forces are the same size. So there's going to be an equation between impulses. Now, this is a vector equation. Okay, so the force of Carl on Bob is the opposite direction. Okay, that's encoded in this minus sign here, of the force of Bob on Carl. And delta t is the same for both. So F delta t has to be equal for both of those guys except for opposite directions. All right? And so that's basically the third law there. Equal but opposite reaction. All right? And it's based on the way the second law works. All right? Now, the quantity mv or m delta v allows us to figure out the concept of momentum. Now, here's the definition. The definition of momentum is mv. The symbol traditionally used or customarily used is a letter P. And I don't know why they use letter P, but so P equals mv, that's the definition of momentum. And so the impulse is really talking about the change of momentum, delta P. All right, so P equal, and this one here in boldface, that's the vector version. Okay, here's the scalar version. M delta V, that's the impulse. That's V2 minus V1, or in full vector notation, boldface V's, V2 minus V1. And mass is a scalar, so it's never bold-faced. Mass has no direction. And so the mass is just a number of, Jihan, it's just a number of kilograms. Okay? So you don't say, well, the mass of this table is 22 kilograms to the north. You just say, the mass of this table is 22 kilograms and be done with it. So it's not a directed quantity, it's just a scale. The fancy word for that is a scalar. Right? Now, here's one way to describe the interaction. Remember, in Galileo's enterprise, physical science, we're trying to find out the truth about the physical world and to communicate it. One way to do that is by writing sentences. Momentum exchange between Bob and Carl are equal but opposite. Or as Sir Isaac Newton said in the third law, equal but opposite reaction. Now, momentum exchange between Bob and Carl, equal but opposite, that's this equation. Delta P for Bob, vector delta P, is equal to the opposite of vector delta P for Carl. Right? those are their exchange momenta. They're the same size, so there's an equal sign. There's no numbers in front, but there is a negative sign in front to indicate opposite direction. All right? And so when you're talking about F delta T equals delta P, yeah, that's what you're talking about. The impulse felt by Bob on Carl is delta P subscript C. Carl's change in momentum. F delta T for Bob is delta P subscript B, the change in momentum. And they exchange it. You know, here's another way you could, we should have done this on Tuesday. I think I'll try this when we get back after the exam. Bring your skateboards on Thursday, if you will. And what I'm going to do is try to get a medicine ball. And we'll get two people on skateboards face to face, and we'll throw a medicine ball between them and see how that changes their states of motion. And that would be like exchanging momentum, because the medicine ball has a mass, a lot of mass, a good medicine ball, and it's going to have a velocity. One guy will get it, the other guy will lose it. Okay, and those are the exchange momenta. And so we'll try to do that demonstration with you next time. Here's a famous postage stamp from Germany. Good old Sir Isaac. Check out the hair. Wow, it's a wig. Anyways, right up here, there's the way that he wrote it. In the background of this postage stamp, you know what else is there? A prism. Sir Isaac Newton is the one that figured out why prisms break sunlight up into the different colors of the rainbow. It's kind of cool. Anyways, famous postage stamp and the impulse equation on the postage stamp. It's a German postage stamp. Now, strategy comment. Impulse as a concept is a good way, usually the easiest way of calculating a stopping time. So for instance, if you have a problem where you have a coin of a certain mass and you send it across the tabletop, eventually it's going to slide to a stop, right? And you can ask yourself how far it goes. You can also ask, how long does it take to stop? Okay, that's the stopping time problem. All right, so now, does this look like a homework problem? Yeah. So expect to see at least one of these, something like this, in homework 6 this weekend. Anyways, here's the wording in bigger letters. Given a coin of mass 0.05 kilograms. So that's a fairly big coin, but it's not unheard of. Sliding across a tabletop from left to right. So I can give a direction to the arrow. I can make a sketch of this, from left to right. At its initial point over here, x1, over here, it has a speed 1.7 meters per second, and it's going to the right. Okay, so I can make a velocity arrow to the right. That's good. It then experiences a frictional force, 0.020 newtons leftward. Okay, so you can write another arrow. Now, it's a force arrow, not a velocity, but you can still write a force arrow, and it's going to be negative. It's leftward. We'll use a negative number for it. And the rest of the problem is it slows down to a stop. It's over here at position 2. So it starts over here at x1, and it stops over here at x2. And you might want to figure out the distance, and you also might want to figure out the stopping time. How long does it take to stop? Okay, and that's what we're going to figure out now. What is the stopping time for this coin? Okay, so the strategy that we're going to follow is to use the impulse equation. So for one thing, we got to figure out delta P, because that's the right hand of the impulse equation. So we got to get P1, and we got to get the initial P1, initial momentum. the momentum at point x1. And then we got to get the final momentum over here at x2. Hey, what's the final momentum? 0, because it stops. So you could write that down right away. P2 equals 0. Ding. Zip zap. Stops. That's the easy one. But P1 we got to calculate. All right. And then we have to use a force on the other side of the impulse equation. So that's going to be my friction force. And so we're going to use friction. Traditionally, we use lowercase f for a friction force. And this one's going to be leftward, so a minus 0.020 newtons. It's pretty small. But the minus sign signifies leftward. All right. And these minus signs there's going to be a minus sign in the delta P. And there's a minus sign explicitly here in little f, the friction force. And they're going to be consistent. They will give us a good a positive number for the stopping time. All right. So let's try to put it together now. Here we go. All right. Down here, P2, I already wrote it down here. It's equal to 0. That's the Cinci one. But P1 is pretty easy too. Mass times velocity. And notice my first statement here, vector P1 is the mass of the coin, 0.05 kilograms, times its velocity, 1.7 meters per second, comma, rightward. Right? Now, the second line down here, I've multiplied the two numbers, and I put a plus sign out in front to signify rightward. All right, so I changed my notation a little bit. All right. And notice that the units here for momentum, a mass times the velocity, kilogram meter per second. All right, so that's good. And then 0 here, so that's good. So now what we're going to do is we're going to take both of those babies and figure out what delta P is, P2 minus P1. Here we go. Okay, P2 is 0, and then we subtract P1, later minus earlier, right? So now my results here for delta P as a vector is negative 0.085 kilogram meter per second, right? Now that's the right-hand side of my impulse equation. Now we got to tackle the left-hand side. You know, F delta T equals delta P. All right, there's delta P. Now we got to do the F delta T side. All right, so there's delta P. All right, here's F delta T. Now, we don't know what delta T is. As a matter of fact, that's what we want to figure out. All right? But we do know what the force is. Okay, it's negative 0.020 newtons. And notice that I have minus signs left and right. So you could cancel right there, ching, if you want. The minus signs are consistent. One comes from the delta. One comes from the direction of the force. Right? And but I'm going to leave them in there for just a minute. All right. Now I'm going to bring the last two items to the top of the next page. So here we go. F delta T equals delta P. The very top. Okay. So there's the impulse equation. And here's my plugins. All right. All right. That's from the previous page. And I still have my minus signs here. I just decided to carry them a little bit longer. And now I want to clear the left-hand side. And so what I'm going to do to clear the left-hand side is to divide both sides by negative 0.020 newtons. All right. And so that means that my left side is now just plain old delta t. And I have a quotient, negative 0.085 and negative 0.020. And you can do that on the calculator. And then notice the denominator here. It's a Newton, kilogram meter per second squared, but it's a fraction in the denominator. So when you divide by a fraction, that's the same as multiplying by the reciprocal. And when you multiply this kilogram meters per second in the numerator times seconds squared per kilogram meter, you just get seconds. Numerically, you get 4.25. And if I've asked you to give me the stopping time to the nearest tenth of a second, Mivosh, ching, 4.3. All right, Abigail.
Do you feel like on tests you're going to be kind of tricky, not necessarily tricky in a negative connotation way, but like with the units and stuff? You know what I mean?
No, I never try to trick people with units, but you're going to have facility with the units. Work them carefully. And if you can remember, you know what the main one to remember? A Newton. If you can remember that a Newton is a kilogram meter per second squared, then pretty much anything you do on the exam is going to fall into place, you know, in terms of canceling and stuff. All right, let's try some impulse calculus. But let me pause for questions on this. Go ahead.
From the last slide,
Wait a minute. What is your name again?
Bria.
Bria. Okay. Question.
From the last slide, when you did P equals MV, why wouldn't the V be negative? Isn't it final minus and it's slowing down?
Yeah, but it's initially going in the rightward direction, so that's positive. All right. So the question was, why wouldn't you use a minus sign to denote the direction? But you would if they were going left, but initially it was going to the right. Another question. Kane. Because the problem states left and right. If you go back and look at the YouTube, you'll see that that's in the, you know, I've got it written out, and there's a diagram too. All right, so you'll be able. And so in terms of trickiness on the exam and stuff, if you do have a problem like this, I'm going to try to make the directions and stuff clear as a bell. All right, so you won't have to worry about that, but you will have to worry about making other decisions. Okay, I hate trick questions. I mean, sometimes I write a question and it turns out that it's a tricky question, but I try not to do it. Sometimes I get caught napping, but usually I try it because I hated them. I hated them when I was a student. So I don't want you guys to, I want you to think, but I don't want to trick you. All right, let's try some impulse calculations. Here we go. Yeah, we got a couple more clicker questions. All right, here we go. Multiple choice. A blob of green jello in space. Read very carefully. Yeah. What's that? No, just how much. When I say how much, that means that's like a quantity, not a direction. That's like asking how big is the vector? How long is it? But not, it could be any direction. But you know, how much is just how long is the vector? So yeah, in this one it would be like kind of slanting off to the right, I guess. So it's three-dimensional. It's in space, so I don't want to, you know. But how much? Yeah. Okay, 20 seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Display. We have got some explaining to do because we have a widespread in what you think is the correct answer. Now, go ahead to the laptop now. There's the correct answer. F delta T. Delta T is 2 seconds. F is 12. Ching. All right, so if you answer, and most of you did answer this one incorrectly, all right, make a note. Impulse, F times delta T, 12 newtons times 2 seconds. And remember, a newton second is the same as kilogram meter per second. All right, next one. Now this one, I want you to calculate a stopping time. All right, so this is just like the coin problem, except we've got a basketball. 0.800 kilograms of mass. And I haven't got a direction specified here, so just do it all with, positive signs everywhere. It should be all right. Because the stopping force is always going to be opposite whatever the velocity is, the initial velocity anyways. Were you watching a movie?
No, I'm looking at my auditions that I have.
Auditions.
I don't know if I'm going to do this one or not. Because it's in Daytona, so it's kind of far.
Oof. Yeah, but you have a Kia. You can get to that.
Yeah, I can, but that doesn't always be on time with traffic. That's what I worry about.
Yeah, that's true. It's always something when you're going to Daytona. All right, 30 seconds. That looks really good. You guys are doing good. Ten, 9, 8. I'll give you another 20 seconds. 10, 9, 8, 7, 6, 5. Come on, type your answers in. What was I at? 6? 5, 4, 3.
I think a couple of people have already left.
Not 70. Wasn't there?
There was like 131.
Oh, there were?
Yeah.
Oh, okay.
Yeah.
5, 4, 3, 2, 1. Click. Okay. All right, good. Go ahead and show the display. Geniuses. You're looking good. Here's the answer. Okay, 1.6. Here's the calculation. Let's just work it out. Chop, chop. Delta P involves 0.80 times times 22. That's 17.6. So that's the right-hand side. The force, 11 newtons on the left. Delta T. So delta T is just the quotient. 17.6 kilogram meters per second divided by 11 newtons. And that works out to 1.6. All right, now, questions about this calculation? Repeat? Yeah, in a stopping problem, P2 is going to be 0, right? Now, a side note here, section 3.6 on uniform circular motion, we're going to bypass that for exam 1. We'll tackle it next Thursday. I was hoping to tackle it today, but we ran out a little bit of time. So, ginormulus homework 6, another try at homework 4. I'll activate it tomorrow morning at the latest, maybe tonight, so be ready. You're dismissed. I'll see you next week for exam 1, 118.